Once again, you're welcome back to our class. My name is Victor Odigoma Ohia. In this class, we are going to be looking at graphical method of representing linear inequality in two variables. Graphical method of representing linear inequality in two variables. So we are going to start from the very simplified ones, and then we progress into the bigger problems. Remember, we have done a lot of work already in linear inequality. So if this is the first time you are coming along or meeting us in this class, just take note that we have done a lot of problems already in linear inequality, so you can check out those videos. All right, so that you can be able to follow us in the one we are doing right now. If, as we are progressing into inequality in two variables, graphical representation of it, we need to understand, how to put up values on the Cartesian plane. Okay, what I mean by that is the x and the y axis. The x and the y axis. Okay, so if we have a problem like this that says x is greater than or equal to -1, and we want to show the area on the Cartesian plane that satisfies this, inequality. What we do is we draw the x and the y axis. It's just a sketch to buttress that or to explain it. Okay, this is x axis as the case may be, and this is y axis as the case may be. Okay, now if somewhere here is -1, do we get? If somewhere here is -1, and what they are telling us is that in this first example is that x is greater or equal to -1. Now, be careful with this thing I'm going to say now. For this symbol, greater than or equal to, we use thick line to show the separation, the boundary line that separates the area that satisfies the inequality and, the area that does not satisfy the inequality. We use thick line for greater than or equal to or less than or equal to. But please take note again. For this symbol, greater than or less than, we use dotted line to separate the boundary line between the area that satisfies the inequality and the area that does not satisfy that inequality. Please, you are going to watch me. If this gram I'm blowing here is too heavy, you are going to see me do, this I'm saying here now when I'll be handling these problems. So please just watch me do it. Remember I said thick line for greater than or equal to or less than or equal to. Now dotted line for less than or equal to or for greater than or equal to or less than or equal to. Okay. Now the area that if x is greater than or equal to -1, I think that range should lie here, lie this way, because this is the area where that all the values that are greater than -1 lie. They lie this way. You understand that? And please, in my concept, secondly, because certain literature, they say the unshaded region is the area that satisfies the inequality or the range of values. But in my own, I use the shaded region, that is the area that satisfies the inequality. I shade it. The implication is that anyone you do, you explain it there. Okay, so as I'm going to say that this is the area that satisfies this inequality, I will shade it. Remember, you use thick line to separate the boundary. So all the values this way satisfy this inequality of x greater than or equals to 1. I'm sure my explanation has, given you the exact information you need. So I will shade this part that satisfy this inequality. That's the simple explanation on that. The shaded region can put it under your this thing, your diagram. Okay, if they say shade the region that satisfy this inequality, okay, or they may not even say shade, they say show the region. When they say show, you know, they didn't tell you either to shade or not to shade. So when they say show the region that satisfy the inequality, when you shade like this, you say the shaded region satisfies the inequality. Okay, so my solution lies on this part. I'm sure that is very clear. What about the second one? Y is greater than minus 2. Y is greater than minus 2. Y is greater than minus 2. What is going to happen there? What is going to happen there? Let's come this way because I'm going to do this one on the other side. Let's see how this place will look like for this. Y greater than minus 2. Y greater than minus 2. So is assuming here is my minus 2. My minus 2. Do you remember what I told you about this sign? This and this. Use what? Dotted line to separate the boundary line, okay, that disconnects the area that satisfies the inequality and the area that does not satisfy the inequality. So I'm going to use dotted line here. I'm going to use dotted line here. Now, y is greater than minus 2. Every value that is greater than minus 2 is this way. Is this way on y-axis. Do you understand? This is x-axis. So every value that satisfies that inequality is this way. So remember I said in my own that I shade the region that satisfies that inequality. So some literature, they say the unshaded region satisfies the inequality. So that explanation there explains what the person have done. Do you understand? The unshaded region, my own is the shaded region. I'm sure you know the difference between the two. Please, so anyone you do, you try to show, you try to, you try to show it. Whether you know you write, you leave that side blank. You you explain it down there. The unshaded region satisfies the inequality. In my own case, the shaded region satisfies the range of values or the inequality. Okay, so let's go to the last one. Let's go to the last one. Um, the last one says, I'll leave all this in, so that as you are seeing them, you'll be understanding, you'll be looking at it again and again. Remember what I said about this? You use tick line, you can see my example there. Remember what I said about this? You use dotted line, you can see my example there. And then I'm trying to use, carry everything, almost everything along at the same time. All right, please. The next, which is example C. Example C. See, C says y plus x. Y plus x is less than 2. How do we show this graphically? How do we show this graphically? Step 1 is write this inequality as a linear equation. Steps. Steps. Show graphically this. Steps. Write the inequality as linear. Let me take my time and do that because I'm interested in your understanding this as a linear equation. So what will happen is that we will now have y plus x equals to what? 2. Do we get? The next step is put either x or y equals to 0. Okay, the essence of that is just to get the intercept of either this or this, either x and y, to get their intercept on the Cartesian plane, the way x and y axis. Okay, so when we say put this equals to, or this equals to 0, it then means I would say when x is 0, do you realize here, comma, that y plus 0 will be equals to 2? That means y is equals to 2. So the y-intercept is 2 on that, what I'm going to show you. Then when y, I put x equals to y, when I put x equals to 0, when y is equals to 0, what is going to happen here? I will have 0 plus x equals to what? 2. That means x is equals to 2. X is equals to 2. Now, I have got both the x and y intercepts. Okay, I've got both of them. I'm checking whether I'm going to do that diagram somewhere here. Okay, I'm sure you have understood what I said about this place. Let me do that diagram somewhere here. So if I have my, this is, okay, this is it. This is x axis, this is y axis, and then x is 2. Let's assume somewhere here is 2, and y is 2. Let's assume somewhere here is 2 for y. Now go back here and check the inequality sign. It's less than, and you know what I told you, that we are going to use dotted lines. If it is less than or equal to, we will use thick lines to separate the region that satisfy that. So I'm going to use dotted lines. I have demarcated the region that satisfies the inequality and the region that does not satisfy it. Now, question: where is the region that satisfies this inequality? Is it this way or this way? Now, if you check this way, you encounter the origin where x is 0 and y is 0. So let's see whether we can obtain a very logical, reasonable inference from here, where x is 0, y is 0. So you now say from here, when x and y equals to 0, both of them is 0, you have 0 plus 0 less than what? 2. Then is 0 less than 2 a true statement? Is it a logically correct statement? Yes. 0 less than 2 is a true logical statement. It then means that this origin is part of the area that satisfies the inequality. Did you get my conclusion? How I did that conclusion? Let me take it again. I will come back here. I want to know, this place is very, very critical. I want to know the area that satisfies this inequality, whether it is this way or it is this way. I will come here and check what is happening at this origin. At that origin, x is 0, y is 0. So if I come back to that inequality and put x, y 0, x 0, I will check what I will obtain. Now what I obtained here now is 0 less than 2. Then 0 less than 2, is it logical? Is it logical? Yes, it is logical because 0 is less than 2. It then means I can now conclude that that origin is inclusive in the area that satisfies the inequality. Remember again that in my own way, I shade the area that satisfies the inequality. In my own way, I shade the area that satisfies the inequality. If in your own way, you choose to leave the area that satisfies the inequality blank, you can say, write it under here, the area that is unshaded satisfies the inequality. Your examiner will understand that this is the area you choose. Okay, whether shaded or not shaded, you have to indicate it down here. Then, like I said, this is the area that satisfies the inequality. And in my own case, I am shading it. I'll say the shaded region satisfies the inequality. Very, very clear. I'm trusting God that what I did here is very, very good enough to help you. This is not the end of it. I'm still going to, this is just single inequality. Where we're heading to is close to Go programming. It's a very higher level, in mathematics. So, but I'm going to get close and get close and get close. Okay. Uh, yeah, let me stop there for the meantime because I wouldn't like to take you to something that is higher than what we are what we're supposed to where we're supposed to stop in our curriculum. Okay, so the next one I'm going to do now is to bring you to a place where we have up to 2 to 3 inequalities that are supposed to appear in one graph, and we are going to see the area that satisfies the three of them at once. So please be in this class. Be in this class. Subscribe to the channel. It's very simple down there. Click on the subscription button, share it to your friends to help them, and then like the video and support us to grow as we are also promoting and supporting you out there. Thank you so much for being part of the class.